The focus of this tutorial will be to introduce users to the VIGOR4 viral genome annotation tool, and specifically options for annotating SARS-CoV-2 genomes. So let's start with explaining what exactly the VIGOR4 tool is. VIGOR4 is a gene prediction program that was developed at JCVI that uses sequence similarity searches against custom protein databases to identify protein coding regions and mature peptides predicted to be produced by proteolytic cleavage. A graphical user interface version of the VIGOR4 SARS-CoV-2 annotation tool can be found on the VIPER website, and I'll be giving you a short walkthrough later in this video. VIGOR4 is also available as a command line program. If you'd like to learn more about it, you can find more information at the VIGOR4 GitHub page shown here. If you'd like to see the specific viral databases and configuration files, you can find them at github.com/jcventerinstitute/vigor_db. So why would anyone want to use this viral annotation tool? Aren't GenBank files already annotated? Well, some are well annotated, but that's not always the case. Sometimes a GenBank record won't contain any annotations at all, and might only provide the sequence or FASTA file. The second issue is that often predicted mature peptides are not annotated. So what does this mean? Well, some viruses, such as coronaviruses, can produce long polypeptides that are then cleaved either by viral or cellular peptidases into smaller functional peptides. In the case of SARS-CoV-2, these proteins are ORF1AB and ORF1A, which are then cleaved into 16 non-structural peptides labeled NSP1 through 16. For example, this GenBank entry has peptides annotated, but this one does not. And finally, while a genome might be thoroughly annotated, the naming schema between multiple records might differ, depending on the annotation software used. For example, you can see in these three genomes the same protein product has been labeled three different ways: putative E2 glycoprotein, putative spike glycoprotein, and S protein. This can make parsing through the data for comparative studies confusing and tedious. VIGOR4 addresses all of these issues by providing standardized annotation based on curated reference sequences for both protein open reading frames and predicted mature peptides. Running your genomes through VIGOR4 will provide you with a standardized dataset that's more amenable to comparative genomic studies. So now, moving on with how to use the VIGOR4 graphical user interface tool on the VIPER website. You can find it by going to viperbrc.org and clicking on VIGOR4 Genome Annotator under the Analyze subsection of the front page. Then select your virus of interest, which in this case is SARS-CoV-2. If you're planning to save your analysis to your workbench, you can give it a name here. Now, there are multiple ways that you can load your sequences to VIPER for analysis. You can analyze your own data by uploading a local FASTA file from your computer. These could either be single genomes or files containing multiple sequences or genomes. The other option is that you can also directly paste in your FASTA formatted sequences of interest. Or finally, if you already have a dataset that you've put together in your workbench, you can select that here. For the purposes of this tutorial, I'm going to just quickly paste in a test FASTA sequence and click Run. So this is what your annotation table will look like. Moving from left to right, we have a VIGOR4 assigned gene identifier, the nucleotide coordinates for the gene name and gene product name, the reference protein used for this annotation, the peptide length, the length of the reference protein and percent identity, and similarity and coverage compared to the reference protein. If you'd like to save your results, you can do so either by clicking on Save Analysis to save to your workbench if you have a Viper account. If you'd like to download them to your own local computer, you can click Download and choose to either download the nucleotide sequences, protein sequences, or all of the annotation files provided by VIGOR4. The VIGOR4 output files will be downloaded as a compressed folder and include a gene prediction file, a complementary DNA file, an alignment file, and a gene feature table that can be used to create GenBank submission files. So that's it for this tutorial. I hope you found it useful, and as usual, if you have any questions or comments, you can get in touch with us by clicking Ask a Question under the Support tab on the Viper website.